columns of my table. So these new arithmetic expressions would take in one or more um, columns from your table, perform some operations on them, and create a new set of attributes for that. We are going to call those attributes as derived attributes, right? Okay. So this also comes in handy later for updating values in a database, but again later. So let's see. So compute the available credit for every credit account, right? So we have our credit account, that is credit ID, limit, that is the entire amount that a person can actually use, and their balance, the amount that they have actually used up, right? So we can say that from credit account, compute limit minus balance and name that as available credit, right? So that says limit minus balance as available credit, and also get me the credit ID as well. And I end up with this view, that is credit ID and available credit, which is essentially the amount after I subtract limit from balance, or balance from, right? Any questions about this? So essentially, up to now, we just talked about project operations, that is just pick me those particular columns. Here we are saying that we could also apply some operations, some arithmetic operations on those columns before we actually create this new table. Okay, should be easy enough. Okay, so now let's talk about some aggregate functions. Most databases allow us some aggregate operations, but mainly these 5 aggregate operations, right? So sum, average, count, mean, max. These are the traditional aggregate of functions that are available to us. Remember that we already talked about finding the max using a rename operations and blah, 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 all of those things. But essentially, if you're implementing a database, you would not be going around doing your max operation like we did earlier, right? Essentially, you would actually look through your table one by one and just figure out what the max is. Same goes for min or count or things like that, right? So essentially, we have certain functions that work across tuples in your database. Right, so that can take values from your database in a column and perform some aggregate operations on those columns. One thing to note, that aggregate functions work on multisets and not sets. So the essential thing to remember about this is, what is the difference between a multiset and a set? A set cannot have duplicate values, whereas a multiset can have duplicate values. So if we are, let's say, counting the number of tuples in a particular column, a set result would get you the unique values counted. However, if we have duplicate values in our table, aggregate function would actually count those duplicates as well. So let's say if I have 14, 20, 20, 21, a count operation on that would result in 4, right? Not 3. Okay, so how do we use, or how do we represent these aggregate functions? So essentially we use this operator called G. G stands for any aggregate function that we can use. So G, so let's say that we want to find the total amount owed to the credit card company. So that is the total amount that is taken out by a customer. So essentially that would be the sum of all balances of all customers, right? So in order to do that, we would just say from credit account, G of sum of balance. Where balance is your column, we just say sum up all the balances, and that would essentially be your aggregate function over the credit account over the column or attribute balance. Similarly, we can also say find the maximum available credit of any account. But before we do that, can someone tell me, let's say that I want to find out the maximum balance in my credit account. So the maximum a user has actually taken out from my credit account. So how would I write that? G max balance from credit account. Exactly, right? So credit account stays, this sum just becomes a max, right? Now, let's say that we have those available limits, right? So that is essentially my limit minus the balance. That is the available amount that I can still spend. So I want to find out the maximum available credit of any account, right? So for that, I can project down the available limits for my account, that is from credit account, compute limit minus balance, and save that as a attribute called available credit, and just perform G of max of available credit, right? So we are now using the attribute derived attribute name available credit to find out the maximum value. In this case, this happens to be this number. Okay, any questions?
I have one question.
Yes.
For the max Gmax available credits,
Mhm.
we need to preset the limit minus balance, or we can just input the Gmax available credit, and we can get the value.
Note that available credit is not one of your attributes. So your computer does not know what available credit is. We need to define what available credit is. So we need to define it specifically what available credit means and then use that in our max operation.
Okay,
Okay,
gotcha. Thank you.
you're welcome. Okay, any other questions? Is generalized projection kind of like assignment? Because you're assigning a new attribute. Yes, it is sort of like assignment, and we will use generalized projection to update our tables later down the line. But remember that an assignment would always create a new variable for you. A generalized projection is sort of like renaming that sense, where available credit is not a new column or a table, right? It just exists within this operation. It does not exist outside. So at any point in time when we execute this particular operation, at no point in time is there a new column being created here. We are just temporarily computing a particular column's value and then performing an operation there. The moment this expression is done computing, that available credit is no longer. Does that make sense, Taha? In that sense, it is different from the assignment operation. Okay, good question. Okay, now let's talk about grouping and aggregation. So sometimes we might want to group up the results and then perform some aggregation operations on those results. So for example, let's go back to our puzzle databases again. We had a puzzle list, that is LTQ, Soma Cube, and Puzzle Box. And we had a list of names that have completed a set of puzzles, right? So what if I wanted to count how many puzzles has each person completed? So in that scenario, Alex would have completed 3 puzzles, Bob would have completed 2 puzzles, and Carl would have completed 3 puzzles, right? Or on the other hand, let's say that I want to know how many people have completed each puzzle. So on that note, Altecruise has been completed by 2 people. Soma Cube is completed by 2 guys, and Puzzle Box is completed by 3 guys, right? So this is where your grouping and aggregation methods work together. So if we want to know how many puzzles has each person completed, what would I need to do? It is better to just, so let's say that I want to count the number of puzzles that has been completed by each person. If I am talking about each person, that means that I'm grouping by person, right? I would group these, values into, in terms of, I would group these values in terms of person names. So Alex, Soma Cube, and Alex Puzzle Box grouped together into the same person name, that's Alex. Bob would be grouped together to Bob Puzzle Box, Bob Soma Cube, and similarly for that for Carl. And then we can just count the number of puzzles Alex has done, then count the number of puzzles Bob has done, and so on, right? So, for example, we would, given these 2 lists, if we want to find out, as I said, how many puzzles has each person completed, we now can say from completed, count the puzzle name, but first we need to perform a grouping operation over name, over person name. So note that the grouping operation is stated on the left-hand side of your aggregate operation, right? So if I make it less complicated, given a table, completed. First, group the table in terms of person name. Given that grouping, count the puzzle names in that set of groups. That is what this does. Okay. So if we look at this thing, so essentially what this does is groups the table into person with respect to person name. So Alex LT Cruz, Alex Soma Cube, Alex Puzzle Box, Puzzle Box, Bob Soma Cube, and so on. And then when we are performing count operation on these groups, we end up with this result, that is Alex 3, Bob 2, and Carl 3. Right? First, group it by person name on the left hand side, then count the puzzle names in that set of groups from the list or from the relation completed. Make sense? Questions? And note that these grouping operations is not necessarily just for count. You can also have them for other aggregate operations as well. Remember that G is just a function for any aggregate operation, sum, min, max, count, what have you. Okay. So that was your grouping operation. So sometimes apart from that, let's think about the fact that sometimes we also want distinct values in our table as well. So let's look at the problem where we say that how many puzzles has each person completed, right? Wait, no. Oh, right, I'm skipping a step here. Okay, my bad. Okay, so let's go back. Yeah, how many puzzles has each person completed? And now we have, let's say, the previous operation that is group by person name. And now instead of completed, we have this new relation that is person name, puzzle name, and completed time. So that is in seconds. So in that scenario, if I perform the previous operation that was person name, group by person name, and count the puzzle names, right? If I perform that, would it still work in this table here? Can someone tell me yes or no? Look at the table carefully, and if I group by person name and count the puzzle names, would it work? What about Alex? Note that Alex basically has solved puzzle name LT Cruz in 350 seconds, but later down the line, he has solved this puzzle again in 290 seconds. Again, it is not ordered. So essentially one is 350 seconds, one is 290 seconds. So if we group by person name, we have the resulting table as Alex LT Cruz 350, Alex Soma Q 45, Alex LT Cruz 290. Right? Now, if we count the number of puzzles in a puzzle name, remember that aggregate operations work on multisets. They are not working on sets, so they allow duplicate values. So if I count the puzzle names for Alex, do I get 2 or do I get 3? 3? Does everyone agree? 3, right? So in such scenarios, we would want to count all puzzle names in that group that are distinct or unique puzzle names, right? We would just want to count LT Cruz just once. So in that scenario, we would just have to say, given your completed times table, count distinct puzzle name when grouping with person name, right? And you can basically add this hyphen distinct to any other aggregate operations to of your choice. You can have it in sum or average. So for example, sum up all the distinct balances in my account. But usually it is mostly used with count in order to count all distinct elements. And it actually makes no sense to have it in min and max. Right? Min or max, right? So essentially, count is the main thing that we use distinct for, but you can also use it